Hey y'all, welcome back. This is video 2 from chapter 7 looking at ionic bonding. And if you remember when we kind of summarized a little bit about ionic bonding, we said ionic bonding is between a metal and a non-metal. It's always the non-metal taking electrons from the metal. This is one way that, that elements can bond. And again, all atoms bond because they want that full valence shell. We can also say that the electronegative difference is greater than 1.7. Okay? There are periodic tables that include the electronegative values of each individual element. We'll see that in general, basically, these two rules kind of go hand in hand and fit together. So let's look at another example. I wrote on the board here two elements, calcium and sulfur. So I want you to identify those two things in the periodic table, maybe pause it for a second till you find them to come up with a couple pieces of information. One, which one's a metal and which one's a non-metal? Or is there one metal and one non-metal? Two, how many valence electrons does each of them have? And third, then, what will be the oxidation number? That's another way of saying what will be the relative charge of that particular ion now after they go. So if you had a chance to look that up now, hopefully you're coming back and you're saying calcium has 2 valence electrons and sulfur has 6, okay? And so when we look at that, we can say calcium loses 2, it loses 2, so it has a charge of +2, sulfur has a charge of -2, and so that's all we have is CaS. If you would have used the kind of shortcut that we talked about at the end of the last video and said calcium is going to form an ion of 2+, and sulfur is going to form an ion of 2-, and we did our crisscross applesauce, we get Ca2S2. And again, if we can simplify that ratio for an ionic compound, we will do it. So it just turns out to be CaS. Now CaS, what do we call that? Is it called a molecule, right? We often are calling anything where we're putting stuff together molecules. And the answer is no. Molecules are only for compounds where we're sharing valence electrons, okay? We call them covalent. We're going to get into that in the next unit. For an ionic compound, we call them a formula unit. So CaS would be a formula unit. But it's important to know that calcium sulfide is made up of 2 different monatomic ions, meaning this is attracted to this because of the difference in charge. The difference in charge allows these things to lock together in a certain pattern that we call a lattice, okay? And so this particular lattice and the lattice of every single ionic compound gives them the properties that we now associate with ionic compounds. So what are those properties? There's properties like they're usually pretty hard. They usually have higher melting points. They usually are brittle to break because they crack along these nice lines here. And again, you can look up some more of the stuff there, but everything has to do with the fact of how it's bonded in looking at its particular characteristics, okay? Again, when we have just one, they're called monatomic ions, okay? Sometimes when we have then more than 1 or 2, specifically, we call them binary ions. But what happens if we have more than 2? Can we have ionic bonds with more than 2? The answer is yes, but we're going to get to that in the next video. Be right back.